Section 14.3 is on right triangles and trigonometric ratios. Recall from geometry the following three trig functions: sine, which is opposite over hypotenuse; cosine, adjacent over hypotenuse; tangent, opposite over adjacent, or SOHCAHTOA. There are three other trig functions that are the reciprocals of sine, cosine, and tangent. They are cosecant, secant, and cotangent. So cosecant is the same as 1 over sine, or hypotenuse over opposite. Secant is equal to 1 over cosine, or hypotenuse over adjacent. And cotangent is equal to 1 over tangent, or adjacent over hypotenuse. Here's a little text box from your textbook that shows some of that. So if theta is an acute angle of the right triangle, and notice that it's centered at the origin on the coordinate plane, then the adjacent side is the one that's on the positive x-axis and refers to the length of x. The opposite side is this vertical line over here, which refers to the height of this point here, and then the radius is the hypotenuse, and the 6 trig ratios are given as I mentioned up above. You'll notice that we're focusing on the first quadrant of the coordinate plane. This is an easy place to start because both of our x and y values are going to be positive. The same ideas and everything that we do applies in the other 3 quadrants with some minor modifications, basically just being aware of when x is positive or negative and when y is positive or negative. Now, when we look at these relationships in a circle with radius of r, we can look at them this way. Let's focus first on the blue circle and triangle in here. You'll notice, I don't know if I can get all of this on the page here, okay. You'll notice that the sine of theta, so I'm looking at the blue theta down here, the sine of theta is opposite over hypotenuse, or y over r. Solving this for y, let's slide this down a little bit. Solving this for y gives us y equals r sine theta, which is the y coordinate on the circle. The same is true for cosine of theta and the x-coordinate on the circle. So the cosine of theta is going to be adjacent over hypotenuse, or x over r. Solving that for x, we get that the x-coordinate is r cosine theta. When we look at this in the other 3 quadrants, we need to keep in mind where the values of x and y are positive and where they are negative. Basically, in the second quadrant, we're going to have negative x's and positive y's. Third quadrant, both x and y are negative, and in the fourth quadrant, x is positive and y is negative. So for example, the sine of a 200-degree angle, which is going to be in the third quadrant, is going to be negative because that's going to be below the x-axis, and down there y is negative. The cosine of a 150-degree angle, which is going to be over in the second quadrant, is also going to be negative because the x values are going to be negative left of the y-axis. Here's an example. We need to find the values of the 6 trig functions for the angle in standard position that is determined by the point -5, -2. So I'm going to start with just a simple sketch. And here we have -5 on the x-axis, and here we have -2 on the y-axis, and that would be this point right here. So the angle that we're looking for is this angle right here. So I need to find the sine, cosine, tangent, cosecant, secant, and cotangent of that angle. So the first thing I notice is I don't need to know what that angle is, but I do want to know what my opposite, hypotenuse, and adjacent are going to be. So I'm going to draw a line to the x-axis so that I make a right triangle there, and I'm just going to transfer that down here because it might be a little easier to see. Okay, so there's my right angle. This distance here is going to be 5. This distance is vertical distance here that corresponds to the shorter side here is going to be 2. And what I need to find is my hypotenuse, which is also going to be the radius. Maybe I'll call it r instead. The radius. And to do that, I'm just going to use the Pythagorean. We could use the distance formula. I think the Pythagorean theorem is a little bit easier. So r squared is equal to 5 squared plus 2 squared, or r is equal to the square root of 5 squared plus 2 squared. 5 squared plus 2 squared is 29, or my radius is going to be the square root of 29, and I'm going to leave it that way because I want the exact values. Okay, now looking at our triangle here in reference to this angle right here, my opposite side is going to be, even though the length is 2, I'm going to refer to that as -2 since we're in the third quadrant. My adjacent to that angle is going to be a -5, and my hypotenuse I found to be the square root of 29. So now I just need to plug those into my trig functions. So the sine of theta is opposite over hypotenuse, or -2 over the square root of 29. Rationalizing my denominator by multiplying by square root of 29 over square root of 29 gives me -2 square root of 29 over 29. Cosine of that angle, cosine of theta, is going to be adjacent over hypotenuse, or square root of -5 over square root of 29. Rationalizing my denominator gives me -5 square root of 29 over 29. Tangent of theta is opposite over adjacent, or -2 over -5, or 2/5. Now to do my reciprocal functions, cosecant of theta is just the reciprocal of sine, so let's go back to here and just flip this. So that's going to be square root of 29 over -2. I think I'll put the negative out front. Secant of theta, that's going to be the reciprocal of cosine, so let's go back to this and just flip it, or negative square root of 29 over 5. And cotangent of theta is the reciprocal of tangent, or 5 over 2. Here's another example. In triangle ABC, C is a right angle, and the cosine of angle A is 24 over 25. Find the sine of A and the tangent of A. So I'm going to start with a little sketch here and draw my right triangle. There's my right angle. My right angle is C, and this says that the cosine of A is 24 over 25, and I know that cosine is adjacent over hypotenuse. Okay, so this is obviously going to be my hypotenuse. This one looks a little bit longer, so I'm going to go ahead and label that one 24. So that means that this angle right here would have to be A, and this would have to be B. So in order to find sine and tangent, I need to find the length of this opposite side right over here. Okay, to do that, I'm going to use the Pythagorean theorem. So the length of BC is equal to, let's do it this way. Let's do 24 squared plus BC squared is equal to 25 squared. I'm going to skip a few steps here. So BC is equal to the square root of 25 squared minus 24 squared, or BC is 7. So that means now that my opposite side is going to be 7 units long. So the sine of angle A is going to be opposite over hypotenuse, or 7 over 25, and the tangent of A is going to be opposite over adjacent, or 7 over 24. These next couple problems we're going to take a look at should look familiar from geometry, so we're just going to use some of the basic trig functions that we learned back then. So, love this one. You're on a sailboat at sea and you spot a 786-foot bluff on the shore. You measure the angle from your sailboat to the top of the bluff and find that it is 16 degrees. You may remember angle of elevation and depression problems from geometry. How far are you from the shore at the foot of the bluff? So let's go ahead and draw a picture here. So there's the bluff, and that is 786 feet. Okay, here's the water, and here is your sailboat. Okay, and then you spot from your sailboat as you look up to the top of the bluff, okay, this angle right here is a 16-degree angle as you look up. And you need to find how far you are from the beach, or the shore, at the edge of the bluff, the foot of the bluff. So basically what we have here is a right triangle. That's a right angle. So in relation to this 16-degree angle, 786 is the side that's opposite, and x is the side that's adjacent. I need to choose the trig function that uses opposite and adjacent, and that would be tangent. So I want to say the tangent of a 16-degree angle is the opposite, which is 786, over the adjacent, which is x. And now I'm just going to solve that for x. I'm going to start by multiplying both sides by x. So x times the tangent of 16 is 786, and then dividing both sides by the tangent of 16. I get that x is equal to 786 over tangent of 16. Make sure your calculator is in degree mode and punch that into your calculator, and we get that that is about 2,741 feet that your boat is from the shore at the foot of the bluff. And our last example here kind of takes it the other direction. I know two of the sides, but I don't know the measure of the angle. So I'm asked to find what is the measure of angle A right here. Now in relation to angle A, 4 is the opposite side and 10 is the hypotenuse. So the trig function that uses opposite and hypotenuse is going to be sine. So I can write that the sine of angle A is equal to 4 over 10. Now recall from geometry that when we want to find the measure of an angle and we're given in a right triangle and we're given the length of two sides, we use the inverse of the trig functions. So from here I can say that the measure of angle A is equal to the inverse sine of 4 over 10. Or in other words, what angle is it that has a sine of 4 over 10? You can punch this into your calculator. Recall that what looks like sine -1 or inverse sine is actually second sine, and I get that the measure of angle A is approximately equal to 23.6 degrees. So in this section we took a look at right triangles and trigonometric ratios. We did a little review of what we covered in geometry and also looked at three new trig functions that are the reciprocals of our given ones: cosecant, which is the reciprocal of sine; secant, the reciprocal of cosine; and cotangent, which is the reciprocal of tangent.